Good morning, everyone. So today we will continue our classes on braking system. So in the last class, we studied about types of brake. Then we will studied about drum brake, disc brake, brake shoe arrangement, and hydraulic brakes, mechanical brakes. We have studied all these many things. So today we are going to study about master and wheel cylinder arrangement and how we are working. Then we are going for anti-lock braking system. Before that, we are going for air brake system as well as vacuum brake system. So these two system we will go, then afterwards we are going for a anti-lock braking system and its purpose and operation. We'll see the anti-lock braking system. So with this we will finish the braking unit. So before going for that one, just we will look into what are the factors that influences the braking effect. We will have the wheel diameter. From the wheel diameter, it is denoted by in terms of radius, that is R2, and then we have the brake shoe and brake lining. Then we have brake drum diameter. So brake drum diameter is represented, that is in terms of radius, it is represented by the R1. Then we have the F1, then F will be the returning force, F1 also returning force in the brake shoe. So what are the things influences this braking effect, that is the retarding force? So first one is the radius of the brake drum and radius of the wheel. So R1, that is represent from the center point to the brake shoe, that is a brake drum. So that radius is denoted by R1, and radius of the wheel, it is denoted by R2. So if you calculate the retarding force required to stop the vehicle, that is given by F1 into R1, that is the force on this brake drum with respect to, that is the torque. We have to calculate. So torque will be, if it is in the one direction, the wheel will be in the other direction, so opposite torque is needed. So hence F into R2 is equal to F1 into R1. So the retarding force required is given by F1 into R1 divided by R2. So where F1 is denoted by retarding force on the brake drum, and this is given by the frictional coefficient of friction and normal force. So that is the force applied by the brake pedal multiplied by the coefficient of friction of this brake shoe. So if you multiply, then you will get the F1. So mu b is represented by the coefficient of friction between the brake lining and the drum, and Fn is the normal force, so that is applied on the brake shoe through the pedals. So from the above equation, we can clearly we can say that retarding force, that is the F, is dependent upon the dimension or size of the brake drum or wheel. So that is nothing but R1 and R2. So it will always depends on the size of F. So sorry, F will be depending on the size of R1 and R2, that is the brake drum and wheel. So based upon that, your retarding force will be calculated, whether you require more retarding force or less retarding force. So that will depends on the dimension of the size. This is the one factor, and other two factors we will discuss. So other two factors will be, the first one is the braking effect. So braking effect, whatever you call the retarding force, can be increased by the area of brake lining. In the brake lining, we have the coefficient of friction. So if you more pressure applied, or area of that brake lining, if you are increased, then the net braking effect also we can increase. Either you can increase the pressure applied on the brake lining through the pedal, that is more pressure if you apply, then braking effect also increases, or else if you make more area within the limit, then the braking effect also we can increase. The last factor is the braking effect also depends on coefficient of friction, that is the mu, whatever you have talked now. So between the braking surface and between tire and road, but too higher friction may cause locking of the wheel, means rotation won't be there, so locking of the wheel will take place, so hence the skidding of the vehicle will be more. So we can't go for too higher friction materials. Nominal friction materials you have to adopt, so that you can't make any locking of the wheels, or skidding of the vehicle can be avoided. So these are the three factors which will influence on the braking effect. So next we will move on to the another type of braking. So that is nothing but last class we studied about hydraulic brakes. In the hydraulic brakes, as soon as you press the pedal, that will operate the master cylinder. Now exactly how it is going to work, that we'll see, and what are the components will be there in the master cylinder. So usually this master cylinder, we will call it as a heart of the hydraulic system. So how exactly it will work? It will work how it is working using the Pascal's law. That is, once you apply the pressure, that is to the brake pedal, through the linkages it will connect it to the piston of this master cylinder. So once you apply this pressure, brake pedal pressure, so that pressure will be transmitted to the your piston. So this piston will act as a column, and that will pressurize your fluid, and that pressurized fluid that is then sent to the brake wheel or wheel cylinder to apply the force. So in this way your pressure is moving from the master cylinder to the wheels. This is how it will works. So your master cylinder is always filled with the fluid, that is called as a brake fluid, uh, and brake lines and wheel cylinders also filled with your brake fluid. So whatever the piston acts on the solid column of the fluid, thus force on the wheel cylinder piston. So when this wheel cylinder piston are pressed against the brake shoes of the drum, so braking effect will be formed. Hence, braking can be done from the master cylinder to the wheel cylinder or to the brake drum. So this is how it will be done. So now see the construction part of this master cylinder. So this here you can see the diagram of a master cylinder. So it consists of one reservoir, that is the brake fluid, which will be there. So from this brake fluid it is going to this combustion chamber. So this reservoir is provided because sometimes whenever you apply the brake or in the line or some other reasons, there might be a loss of your fluid. So to compensate this loss, we have to provide some kind of reservoir for this fluid. So fluid reservoir will be there. So that fluid reservoir, it will be going from the intake port, and it will fill the fluid whenever it is brake is in a released position. So in this way, this compression chamber will be filled by the fluid whenever there is a loss in the brake fluid. So this chamber, it is uh, meant to the air vent, so that a normal pressure will always acting upon your top of the fluid. So hence atmospheric pressure fluid, it can go inside your chamber. So we have to make sure that atmospheric pressure only it will work. Next we have the compression chamber. So this compression chamber consists of aluminum piston, which is covered with rubber seals. We can see over here the rubber seals will be provided, and also it is provided with the piston holes. So this rubber seal, what is why you are providing? Because this fluid over here, it should not go on the other side. For that reason, rubber seal will be provided. And then we have over here we have the fluid check valve. So and we are having the springs, and we are having the rubber cups. So this whenever the we are pressing the pedal through push rod. So push rod will be there. This is connected to your linkages from the brake pedal. From the brake pedal, it is coming to the push rod. Push rod will push us to your piston, and piston will having over here spring. It has to press against the spring. The spring will comes in contact with the your rubber cap to the fluid check valve. So whenever how it will works, exactly how it will works. So whenever the brake pedal is pressed, this push rod, so whatever the push rod you are talking about, this push rod pushes your piston to the inward movement, that is on the left movement, leftwards it will move, and against the spring force. So whenever it crosses this bypass port, your fluid will have the desired pressure, and further movement of the piston will build up the pressure in the compression chamber. This will opens your check valve. So this will opens your check valve. So whenever that desired pressure is reached, this will opens the check valve, and fluid will forces or pressurized fluid will forces into the brake lines through this check valve. So this is how exactly working of your master cylinder. So whenever the brake pedal is released, what will happen? This piston will move towards the right. So check valve allows the fluid pressure to come back over this compression chamber, or compression chamber, and spring action will be there, that will be pushes your piston towards the right, and fluid under pressure will be left this check valve and off seat, and allowing the fluid into the compression chamber. So this is how exactly your master cylinder works. Next we will move on to the wheel cylinder. So now from master cylinder, whatever the pressurized fluid will be there, so that pressurized fluid that is going to the each and every wheel cylinder. So if four wheels are there, four wheel cylinder will be there, that applied fluid will going into the your wheel cylinder. So now we will check how the wheel cylinder arrangement will be there. So whatever the pressurized fluid, it will comes over here, that is the intake port. In the intake port, from that we are having the piston and the cylinder arrangement. So this is the cylinder block housing, we will call entire housing. In that two pistons will be there. Here two pistons, remember. So piston one is this one, piston two is this one. Then we will have the springs will be there, return springs will be there. Next rubber cap will be there. Next because rubber cap is provided so that oil should not go to the other side. Next we will have the rubber seal, then linkages, then seal spreader, and a blender port. So whenever this brake pedal is means pressurized fluid coming from the intake port, and which will be pressurize this piston, and this piston will move towards the left, and this piston move towards the right. So whenever this piston is moving, this is connected to your brake shoe, and brake shoe will be comes in contact with the brake drum, hence braking effect can be done. So this is outward movement of the piston due to pressurized force of the fluid. It will braking system can be happen. So this is how your working of the wheel cylinder will be. So when the brake are released, this fluid will goes again, pressurized fluid will goes to the normal position. Then piston will moves, because this spring will bring back the piston to the normal position. So this is how your wheel cylinder will works. So this is the main importance, master and wheel cylinder, working of the master and wheel cylinder construction and its operation. So make a note of this one, master cylinder arrangement. Next we will move on to the advantage and disadvantage. So what are the advantage of this system, hydraulic braking system? So one is the fluid pressure is same, so same amount of braking force you can obtain on the all the wheels. So braking effort will be same for the all the wheels. Next, comparatively rate of wear will be less due to absence of joints, because only fluid pressure will be there, that will be pressurized instead of mechanical linkages, and the wear percentage will be less. This system is self-lubricating because oil is used, so lubrication is not needed, separate lubrication is not needed. Earlier mechanical linkages were used, so lubrication is a major issue was there. So now there is need not be a lubrication. And due to absence of joints, brake linkage, and it will be simple in construction, so there won't be any mechanical linkages or any joints won't be there, and construction is a very easy part. So now we will move on to the disadvantage. So what are the disadvantage? So it is suitable for intermittent brake application, which is normal brake application, but these are not available for your parking purposes. Next, even small leakage, if it is there in the line or anywhere, so air will go inside the system and brakes become useless, or braking effect will be keep on reduces, and we won't get the proper braking system. So that is the major issue if there is any kind of a leakage. So these are the advantage and disadvantage of your hydraulic braking system. So next we will move on to the power brakes, very important. So power brakes. So why you asked power brakes? So in lighter vehicles, no issues. Disc brake, drum brake, you can use. And whenever the heavy vehicle comes like buses, trucks, so we need more pressure because weight of the vehicle is more, and we need more pressure. So that means the application of force on the brake pedal will increase as the weight increases, and there need some kind of device or some kind of linkages, so that applying a small pressure also it has to be doubled, the pressure force has to be doubled on the wheels. So how we are going to make that system? So that is nothing but your power brakes. So power brakes are used to reduce the amount of pedal pressure force to necessary to stop the vehicle. So if pressure force is applying by the driver is most, that means driver will be in uncomfortable position, so you may have fatigue in your nature. So to avoid that one, we need that power brakes. Uh, this if energy for these brakes are taken from the transmission of the vehicle itself, which partly helps the driver, and driver still has to put some effort, means without effort we can't do this one, but he has to put some kind of effort, so while applying the brakes, and that some effort will be transferred into large way, means larger pressure will be provided in the wheels. So that kind of mechanism, or that kind of such brakes are called as power brakes, or it is one another name is called as servo brakes. So practically, when none of the braking effort also not put by the driver, the brakes are termed as a power brakes or power operated brakes. So the mechanism which supplements this kind of brakes, so that brakes mechanism is known as servo mechanism. So mainly we have to give the more pressure for this power brakes, so that kind of brakes are known as power brakes, and that mechanism is known as servo mechanism. This servo action or self energization of the brakes helps driver to apply the brakes without a fatigue. So earlier days we are used to old kind of system, that is mechanical servos are used. Now that kind are obsolete, so power brakes are very much used in the system. So in vacuum servo brakes, the brakes applied by utilizing the engine suction from the intake manifold. So these are the kind of how you can do the power to the fluid pressure while applying the small force. So that mechanism we can do by two ways actually. In the first type, so in the both the cases we will have the piston or diaphragm operating on the cylinder, which will be incorporated with the suitable linkages. So in the first type, what will happen, both side of the piston, so just assume one cylinder is there, one piston is there. Okay, one side of the cylinder or both side of the cylinder we will have exposed to the atmosphere. That what will happen, both side will have the same kind of pressure, so the piston won't move. Okay, so that is the condition where the brakes are not applied. So when the brakes are applied, what will happen, one side will be connected to the engine vacuum and one side it is the atmospheric pressure. That means both side of the piston we will have the different pressure, so differential pressure is exist, so that causes piston will move towards the vacuum side, and that movement can be taken, and hence that will be powerized your brakes. So that is the one kind. And in the second type, what will happen, in the first type we have both side atmospheric pressure, instead of both side atmospheric pressure, in the second type we will have the both side engine vacuum. So in the both side, if we have engine vacuum, and while pressing the brake pedal, one side it is exposed to the atmosphere. So once again we have achieved the difference in the pressure. Due to difference in the pressure, what will happen, your piston will move and hence power braking can be obtained. So in this way we can do this power braking. Just we will see the, so in the diagram you can check in the first type what will happen, we have the cylinder arrangement and piston will be there. So two side of the cylinder it is exposed to the atmosphere. So this is the condition where brakes are released position, or we are not applying the brakes, and then both side same pressure, piston won't move. Okay, when the brake is applied, one side atmospheric will be there, one side vacuum will be there. That means pressure difference will be there. So higher pressure will pushes this piston towards the lower pressure, hence there will be mechanism, means movement of the piston will be there. That movement can be utilized for the power braking mechanism. So this is how the first type will work. Whereas in the second type, instead of atmospheric pressure, we will have the vacuum pressure. That can be, vacuum pressure can be taken from the engine manifold, intake manifold. So you have seen in your vehicles, four-wheeler, especially four-wheeler or heavier vehicles, you have seen there is a engine vacuum pipe will be there in the intake manifold. So many times you have seen this one. That is given for your braking system. So engine vacuum will be there both side of the cylinder, so both side we will have the same pressure, so hence there won't be any movement of this piston. So whenever the brakes is applied, what will happen, one side it is coming to the atmosphere, one side it is vacuum. So once again higher pressure will be the atmospheric side, so this will push us to your piston, so piston movement will be there. Once the piston movement is there, that can be utilized for your power braking system. In the second type are more prefer than the first type, because the action will be more rapid, so hence this type will be more preferred than this type. So second type is called as suspended vacuum system. So suspended vacuum system is more adaptable than that of the first type. So now we will move on to the actual working of this power brake. So power brakes, how it will work. So, this is one type of servo vacuum or power brake. So it consists of your piston and cylinder arrangement. We can see over here, piston will be there, cylinder will be there, booster cylinder and piston will be there. And this piston is connected to the linkages through the brake pedal, and another side of piston is connected to the master cylinder. So push rod will be there. Okay, so from the master cylinder it is going to the your brake lines or wheel cylinder. So this is how your arrangement will be there. um, when the brake is applied, what will happen when brake is applied? The control valve is there, that will closes off atmospheric pressure. Control valve is closes off atmospheric pressure. So to the master cylinder portion of the piston, that is right side of the your piston. So further movement of the brake pedal opens your vacuum inlet. So vacuum inlet will be opened, so vacuum is created. So one side we will have the atmospheric pressure. So whenever the brake pressure is applied, this side atmospheric is closed, vacuum will be operated, so vacuum will comes over here. So there will be the pressure difference will be created. So once the pressure difference is created, so atmospheric pressure will act on this piston. So along with your brake force, atmospheric pressure also acts on this piston. That means we are giving the more pressure on this piston, so movement will be more, and so pressure will be more on this master cylinder. So and so this kind of this one is known as simplified version of your power brake system. So this is actually first kind what we are told, which is not suitable actually. So second type we will once again we will explain. So in this type, once again I will explain. So we will have the atmospheric pressure side over here. So cylinder, piston, and in the piston we have the push rod. Push rod, one end is connected to the brake pedal, one end is connected to your master cylinder. Initially, whenever a brake is not applied, both sides will have the atmospheric pressure. One control valve will be there. So here it is not shown actually. Control valve will be there. So whenever this brake pedal applies, this control valve will be closed and vacuum will be created. So vacuum will be there, less pressure. Here will be the atmospheric pressure. So more force will be act on the cylinder, that will move towards your right, and so this push rod will be movement will be larger. So pressure created over here will be larger. So that higher pressure will be given to all four cylinders. This is how your working of the power brakes will be done. So next, same thing. So whenever you talk about power brake, three stages of operation will be there. That is one brake release condition, applying brake condition, and holding that constant pressure. So brake release, apply brake. That two condition you know, and holding the constant pressure. So once you brake apply, that constant pressure has to be hold. So three stages of your power brakes. So next system we will move on the power brakes, that is known as vacuum servo brakes. So this is actually the second kind whatever you talk in the power brakes. So in this we will have the vacuum reservoir. That vacuum reservoir which will be connected to the intake manifold through the non-return valve. Only one side it can take the direction of the fluid, and from this we have the servo cylinder, which is very important. Servo cylinder is connected to your vacuum reservoir as well as a control unit, and we have the master cylinder. Master cylinder fluid will have the arrangement fluid which will pushes this piston to the push rod to this valve. So we have two valves in the control unit. One is valve A, one is valve B. So against the spring will be there. So what will happen, sir? This is also connected to the vacuum. Whenever your what you will call brake is not in operation, or you are not press the brake, so brake release position we will call. Whenever the brake release position will be there, this vacuum will be there. So that vacuum will be acting on this servo cylinder, as well as this is also connected to the another side of your servo cylinder. So both side will have the vacuum, so there is no movement of this piston. Got it? So whenever this brake pedal we are applying the brake pedal, what will happen, whenever this brake pedal is operated, this fluid in the master cylinder that will pushes this push rod or piston due to piston arrangement. So what will happen? Valve B will be closed. See over here, valve. So this valve B will be closed, and what will happen? Automatically valve A will be open. This valve A is open to atmospheric pressure. So valve A is closed. That means vacuum can go to this side. Only atmospheric pressure will be going over here, and which will act on this servo cylinder. And one side we have the vacuum, and now one side we have the atmospheric pressure. So that due to pressure difference between the piston, this atmospheric pressure will push us this piston, and movement of this piston is directly connected to your through linkages through the master cylinder. That means once you apply the brake pedal, along with the brake pedal force, we have the movement of the piston also. Due to linkages, more pressure will be applied on the master cylinder fluid. So this is how your servo brake, vacuum servo brakes are working. So once again I will explain. Vacuum reservoir will be there, so that vacuum is stored from your intake manifold through non-return valve. So this vacuum reservoir which will connect your control unit as well as servo cylinder, one side of the servo cylinder, and servo cylinder other side it is connected to the control valve, control unit. In the control unit we will have the two valves, one is valve A, one more is the valve B. So this control unit is connected to the master cylinder to the piston cylinder arrangement. So whenever you are in a brake release position, or whenever you are not applied the brake, the condition will be valve A will be closed, so valve B will be in the open position. So that means vacuum is coming over here, and it is acting opposite to this acting in the one side of the servo cylinder, and one more side again vacuum will be there. That means two side we have the same kind of pressure there, and so there is no movement of this piston. That means we don't have any pressurized fluid over in the master cylinder. Once you apply the brake pedal, what will happen? This will push us, the oil will push us this piston. That means valve B will be closed and valve A will be open. Since valve A is open to atmospheric pressure will fill this over here, and that will becomes and acts on this cylinder piston of servo cylinder. Another side vacuum, since there is a pressure difference, the movement will be towards the right, and this movement will be going to your brakes to the master cylinder through the linkages, and more pressurized will be done. So that is nothing but power brakes. So this is exactly how the power brakes are working. I think you have understood the concept of this power brake. Same thing I've written in the writings. Next, we will have the air brakes. So, air brakes. This is another way you are doing the braking unit for heavier vehicles. That is using your compressed air. So, in this unit, we will have the compressor. Uh, so, we will move on to construction and operation part. So here you can see air will be there. So air will be coming through this air filter. So what will happen? Air filter that will remove the contaminant present in the air, like dust or any other particles whichever present in the air, that can be removed from the air filter. So then it is passes through the compressor. So you can see over here compressor is driven by the, because it is a power absorbing device, and it requires the power. So that power is taken from the engine itself. So engine itself takes from the engine itself it takes the power, and compressor will works. So that will raises the pressure of the air, whatever the required pressure is there. So till that it will rises, then it is going through the unloader valve. So this valve mainly consists of whatever you talking about this unloader valve. This mainly consists of governor valve, plunger, and non-return valve. So three valves will be the governor valve, plunger, and non-return valve, and it regulates the pressure in the system. So pressure will be set by this valve. So the required pressure only, then only it will operate and it will send to the system. and a reservoir or air tank will be made. So whatever the pressurized air will be there, so that will be stored in the tank. So for the specified pressure, and whenever braking is required, then you can take it from this reservoir. So from this reservoir it is going to the brake valve, or we will call it as application valve, used to regulate the braking intensity in the air pressure system. From the brake valve it supplies the air to the various brake chambers. So wherever the brake chambers are there, this will supply the air, and this pressurized air converted to useful mechanical work, that is piston movement will be created in the wheel cylinder will be there, that piston movement will be created, and once the wheel cylinder is operated, that means you are done with the braking application. So the movement in the wheel cylinder, whatever wheel cylinder we are using for all the wheels, that movement is caused by the compressed air. So since it is caused by the compressed air mechanism, so that type of braking systems are known as air brake system. So this is how your air brake will work. Same thing written over here. So this is how operation of the air brakes will be there. So air will coming from the atmospheric, which will be filtered through air filter. Then it is going to the compressor. It will set by the required pressure, that air, and required pressure. Once it reaches, unloader valve will be open and it will stored in your reservoir. So this reservoir mainly used for your braking unit, and several other purpose also you can use. From this reservoir it will goes to the brake valves. So from the brake valve it will supplies the air to the wheel cylinder of each wheel. So if it is four wheel will supplies that through the brake wheel. Air will be compressed air will be supplied to the brake wheel, and compressed air will be pressurized air. Whatever the compressed air will be there, that will convert that pressure energy into mechanical work in the wheel cylinders, and so piston movement will be there, and so braking of the system will taking place. So this is how your air brake system works. Next we will have a anti-lock braking system. So anti-lock braking system is nothing but it is a controlling of braking through electronic way or through programmable way. So mainly it will consist of so many electronic parts, so many sensors and valves. So some signals it will send to one programmable unit, and according to that it will tells which wheel is required more pressure, which wheel is required less pressure, and according to that pressure will braking will act, and the controlling of the braking will be done by the anti-lock braking system. So anti-lock braking system is an automobile safety system or automobile braking safety system, which allows the wheel on the motor vehicle to maintain the tractive contact with the road surface. Remember, it will maintain tractive contact with the road surface according to the driver input while braking, and preventing the wheel from the locking up, means ceasing of the rotation. For example, during the skidding or a slippery road will be there, then what will happen, sir? During the slippery road your wheel may not able to turn, or wheel may not be able to rotate, that is meaning by ceasing of the rotation. During that condition your ABS will work properly. You can see over here. So whenever the slippery road is there, if you don't have ABS system in your car, so you may not get a proper control in the system, so skidding or of the vehicle may take place. If it is ABS is there, then you can go smoothly in the drive condition or road condition according to this road condition. So it will have a better control for the driver ABS. So generally this ABS offers improved vehicle control and decreases the stopping distances on a dry and slippery road for the drivers. However, so these loose surfaces like gravel or snow covered prevent, ABS can significantly increases the braking distance. Although controlling is done, but braking distance may increase. That's it. Uh, in ABS system, what will happen? We will have electronically control. So we will just we will move on to operation of this ABS system. So ABS system, how it will operate. So typically this ABS system we will call it as a CAP, or another name for ABS is a controller anti-lock brake, that is known as CAP. So what are the units it will contain? One is electronic control unit, mainly we will call it as ECU. So electronically it will control, and we will have speed sensor on each wheel. We have the speed sensor, and at least we need two hydraulic wires within the brake hydraulics. So what will happen, this ECU, whatever the controller unit is there, that will continuously it will monitor the speed of each wheel. If you find, if this unit will find any wheel is rotating lesser speed than other three wheels, any one for particular, if you take example, one wheel is rotating lesser speed than other wheel, so that signal will send to the ECU, to the braking system, and braking system will act upon whatever signal is sent by the ECU. That means whatever the lesser speed will be there, for that less pressure force is required to stop the vehicle, because the rotational speed of that wheel is less, since lesser force is required, so only less force it will send to that wheel, and for other wheel whatever the required force is, then that force, so pressurized fluid will be sent. Hence for stopping the vehicle, all will four wheel will stop together, and so there won't be any proper skidding of the vehicle may not be there. Controversially, if you take one wheel is rotating faster than other three wheels, what will happen? So it will send a signal, if you will detect that one, and it will send a signal to the braking unit. So braking unit, what it will does, it will pressurize the more force for that wheel, means the speed of that wheel is more, and it requires more force to stop that wheel, and so it will send the more pressurized force fluid to that wheel, and the other three will have the lesser pressurized force, and in this way, we can stop all the four vehicles together. That means control over that wheel will be more important. So we are having the more control on the wheels, and it's a slippery region or skidding region, it will act very effectively, this ABS system. So this process will be repeated continuously and can be detected by the driver via brake pedal pulsation. So in this way, your ABS system will work. So because of this, wheels of the car equipped with ABS are practically impossible to lock the wheels. That means seizing of the uh, wheels are not possible, or it is very less whenever you are having a ABS system in the car. So this ECU is the programmable unit, and also this ECU disregard the difference in the wheel relative speed below the critical threshold. That means it will set some threshold speed limit or speed difference it has to set. Means very less speed difference it may happen due to turning, because in the turning, while car is taking the turning, the outer wheel has to rotate speeder than the inner wheel. So there is a speed difference will occurs. So during that time, ABS should not work. So for that reason, one threshold limit has been given for your ECU. If that limit only crossed, then only ECU sends the signal for the braking unit. Otherwise, it won't send. So depending upon the condition, so we have to program in such a way that controlling unit has to be programmed in such a way that all the condition it has to satisfy. So it directly, one small difference if it is there in the wheel, so it ABS may not work. So there is a particular limit it should be there, then only should send the signal to the braking system. So this is how your ABS will work. If a faulty develops in any part of the ABS, a warning light will be illuminated in the panel or dashboard of your car, so that driver can recognize there is ABS system is disabled and it is not working. So this is how driver will come into picture, that is ABS is not working, so that you can see the means you can stop the vehicle in a proper way. So modern ABS will apply individual brake pressure for all four wheels through the control system of up mounted on sensor and dedicated microcontroller. And ABS will be offered or come standard on most standard vehicles nowadays. Most of all vehicles will have the ABS system in this vehicle. So in spite of cost, also ABS will be preferred. And a modern electronic stability control system are evolution of ABS concept. So along with this sensor, there will be two additional sensor will work together in this system. So one is the steering wheel angle sensor, and one more is the gyroscopic sensor. So what actually it will does, gyroscopic sensor detects the direction taken by the car does not coincide with the steering wheel sensor reports, and ESC software will be break the necessary individual wheels, so vehicle will goes in a proper way. So gyroscopic sensor that detects in which direction your vehicle will be taken, or left or right, so depending upon the, it will doesn't depend on the steering sensor, and your braking system software will develop a signal for individual wheels how much braking has to be done, and steering wheel has to sense the operation of a cornering braking brake control, CBC, cornering brake control. Since this will tells the ABC that wheels on the inside, the curve should brake more than the wheels on the outside, and by how much. So outer wheel, whether you have to take a move or less, how much braking should be done while taking the turn, or that is known as cornering brake control, that is done by your steering wheel sensor. Depending upon how much turn you are taking on the steering, so that sends the signal, and cornering brake control will be actuated, so that for outer wheel how much brake has to apply, inner wheel how much brake has to apply, how much time it has to take that braking. So this menu will calculate automatically, so everything will be electronically controlled. So whenever ABS is there in the vehicle, the traction control system will be implemented on the acceleration of the vehicle. So whenever the acceleration is taking place, you should not take any means traction should be there between your wheel and the road surfaces, then only it is possible to stop the vehicle. So ABS will take care of that controller, and it can detect the situation. According to that the situation, your braking system will be applied. So nowadays ABS is very important for all the vehicles. So this is how ABS will work. So many sensors will be there. So based upon the sensor signal, it will takes the input signal from sensor, and it will gives the output for your braking unit. So hence braking will be worked in the effective way. So whether it is a slippery road or skidding road, or you are running very fast, so if you are losing the traction, so ABS should work. So all those things will be adapted in this system, and hence more controlling of the braking is done by the anti-lock braking system. Okay, so this is how your ABS operation and purpose of ABS operation is done. So now next we will see what are the components, or what are the main component. Only main component we will discuss very briefly. We are not going in depth of this system. Very briefly we will go through this component of the system. So we will have the four component. One is the speed center, valves, pump, and control. You can check one because in this system we don't have a diagram, so because all the things will be electronically controlled in it, and so we don't have a diagram. But somehow we can write like this: ABS one ECU unit that will be signal taken from this speed sensor, rear speed sensor, then it will give the output for your braking unit. So this is how it will works. So four components, main components. One is the speed center, next valves, brake valves, then we require pump and controller. The speed sensor, we'll go for speed sensor. So speed sensor, actually it will determine how much speed your wheel is going to rotate. So in this we are providing a magnet and coil of wire to generate the signal. So whenever the magnet and coil is placed, one will be having the rotor and one will be in the stator. So whenever a rotor rotates, there will be production of magnetic flux. Once speed is constant, your magnetic flux will be constant, and hence that magnetic flux, from that magnetic flux it will generate the voltage in the sensor, and that voltage it is will be the input for your ECU. So that voltage it is keeps on recorded or keeps on noted by the ECU whenever there is a drop in the speed, or whenever there is a more speed is obtained compared to other wheels, it will compass that speed with each wheel compass with other three wheels. So whenever any wheel is lagging behind, or whenever there is a wheel is having more speed, then that signal is sent to the braking. So in this way speed sensor will works. We'll have the valves. So there will be a valve in the brake line of each brake controller by the ABS. On the system, we have the three position. Valve will be in the three position. The first position, valve is in an open condition. So whenever the valve is in an open condition, pressure from the master cylinder is passed right through the brake. So pressure will be passed from the master cylinder to brake. In position 2, valve blocks the line. So that is isolating the brake from the master cylinder. So what will happen? This prevents whenever there is isolation will be there from the brake from the master cylinder. This prevents the pressure from rising further, and should not drive or push the brake pedal harder. So just to be softly can push that brake pedal harder, brake pedal, and so it won't. It will prevent that brake pressure from rising the pressure. Next position, the valve releases some pressure from the brake. So that will be the third position. So the majority of the problems with the valve system occur due to clogged valves. So there will be a blockage in the valves due to this fluid. So this is how your valves are going to work. Next, we will have the pump. Pump, as already you know, what he has to do. The main function is to restore the pressure in the hydraulic brakes. After a brake pedal is released, sometimes there will be loss in the pressure. Then sometimes the fluid will be lost. So you have to maintain that same pressure in the hydraulic brakes. So pump will does that function of that one. So a signal is sent from the controller to the valve. So whenever there is a wheel slip, will be there detection of wheel slip, and it will maintain that same pressure. After valve releases, pressure is supplied from the pump, and it will be restore the pressure to the braking system. Next, controller is nothing but it is a programmable unit. Already it is programmed, microprocessor programming. So it has to take the signal from several individual sensors, so many sensors. Usually it is mainly speed sensor and some other sensor. It will take the signals, and depending upon the input signal, it will calculate how much force or how much pressure has to be sent, and it will give that signal to your respective braking system. So this is how your controller works, and this will limit the brake load. So how much brake has to be applied, how much time it has to apply. So that signal is sent to the your braking unit or ABS modulator, which will act the braking valve on or off, and duration of that on and off condition of this braking valve. So this is how your controller will work. So this will completes your ABS part. So that means entire braking unit has been completed. That means entire module 2 is completed. So we will have the braking system as well as transmission system. Both the chapters is finished. So hence module 2 is finished. So next we'll go for the module 2. So you go through the all the videos of module 2. So any doubt, you try to clarify yourself, or else you can contact me for any kind of doubt. So all the best, do it well.